So the frequently asked questions we can expect is the difference between crystalline and amorphous solids, applications of surface tension and viscosity concept, then gas laws and numerical problems, then phase transition and critical phenomena. Hi everyone, welcome back to my channel. So today's video topic is states of matter. So here we are going to discuss regarding the different states of matter. So first of all, what is matter? So matter is nothing but anything which is having some mass and it is going to occupy some space. So anything which is having matter and it is going to any matter which is going to have mass and it is going to occupy some space. So this substance or this thing is called as matter. So then what is the classification of this matter? So the matter is classified in three main categories. The first one is solid, liquid and gas. So this classification is based on the arrangement, molecular arrangement and intermolecular forces and energy of the particles. So these are the three basic criteria which are taken under consideration to categorize this matter, that is solid, liquid and gas. Then intermolecular forces, or you can say IMF. So the intermolecular forces in the solid is very strong, and liquid it is moderate, and in the gas the intermolecular forces is very weak. The types of intermolecular forces: first one is van der Waals forces, then hydrogen bonding and dipole interactions. So here we can see one table is there, that is basic comparison table. In this table we are going to compare the different states of matter like solid, liquid and gas. The first property we can take as shape. In the solid the shape is fixed, but in the liquid there is no fixed shape, and in the gas there is no shape at all. And volume. In solid the volume is fixed, and liquid of course the volume is fixed, but in the gas there is no fixed volume. Compressibility. Here in the solid very negligible, in the liquid it has but low. Then gas, here the compressibility property is high. So molecular motion, here vibrational motion is there, here the motion is transitional, and here there is a random motion. Now about solid state. So solids are the substances which are having a definite shape, means fixed shape, and volume. So solid it is a substance which is having a definite shape and a definite size or volume. So types of solids. There are two different types of solids. One is crystalline solid, another one is amorphous solids. So how they differ means, crystalline solids have regular arrangement of particles, whereas amorphous solids have irregular arrangement of particles. Here they have sharp melting point, they don't have sharp melting point. They are anisotropic in nature and they are isotropic in nature. Anisotropic in nature means when we are going to subject any solid substance for the study, for example light, heat or conductivity. So suppose we are going to expose the solid substance in any of these parameters, so when we measure the values, so it shows different values in different directions. Means when we analyze the by passing light, or when we are going to pass the heat or conductivity, when we are going to measure in different direction, for example here one direction, for example here separate directions, for example here we are going to analyze in a different direction, then we are getting the different values. Similarly, isotropic means, so when the solid substance is exposed to analytical parameters, like we are going to pass the light, we are going to pass the heat, or we are going to pass any conductivity, so then in all the directions we are getting the same values. So this phenomena is called as isotropic and anisotropic. Then it is having definite geometrical shape. So crystalline solids having definite geometrical shape, they don't have any definite shape. Example for this category is sodium chloride, sucrose, quartz, copper. And here amorphous solids example is glass, plastic, rubber. Then what is the pharmaceutical importance here? So the nature, whether it is crystalline or amorphous, is taken under consideration because it affects the drug stability, it affects the solubility, of course it affects the bioavailability. Example, amorphous drugs are more soluble, higher bioavailability, and then best, but they are less stable as compared to crystalline. Now about the gaseous state. So gases have no fixed shape or volume and are highly compressible. So what are the basic characteristics of these gases? So they are having large intermolecular distance, means the distance between the molecules is very large. Then they have high kinetic energy. Then the motion is random, that is not in a straight direction or in a specific direction, the motion of the molecule is random. Then here is the gas law, that is first one is Boyle's law. Here P is inversely proportional to 1 by V, that is volume. So at constant temperature, pressure is inversely proportional to volume, means as the pressure increases the volume decreases, as the volume increases the pressure is going to decrease, that is at constant temperature. Then Charles law, here at constant pressure the volume is directly proportional to temperature, means the volume is directly proportional to temperature, means as the volume increases, as the temperature increases, the volume also increases, it is directly proportional to. Here there is an ideal gas equation. So PV is equal to N into RT. Here P is equal to pressure, V is equal to volume, N is equal to number of moles, R is equal to gas constant, then T is equal to absolute temperature. So here there are some pharmaceutical applications here. It is mainly used in aerosol preparations and it is used in inhalation therapy. Now the topic is phase transitions. So means here there is a interconversion of states, means from solid to liquid and from liquid to gas. So when we melt the solid, it get converted into liquid. So when we are going to freeze the liquid, again it is converted into solid. Then when we are going to apply the temperature, so liquid get vaporized and it converted in the form of gas. So when we condense the gas, again it is converted into liquid. But when we are going to apply this sublimation for the gas is directly converted into solid form, that is deposition. So then critical temperature. So what is critical temperature here? The critical temperature above which a gas is liquefied by pressure alone. Means critical temperature is the temperature where the gas is liquefied by using pressure alone. Then what is triple point? So triple point is the point at which all the three states, that is solid, liquid and gas, they coexist in equilibrium. They are present in equilibrium condition. So that is called as triple point. Then here some points are there which is supposed to be revised. That is amorphous solids, they are having high solubility but less stability. Crystalline solids, they are more stable but less soluble. Then gases, they follow gas laws, highly compressible. Then liquids, the viscosity and the surface tension are very important, and phase transition occurs at specific conditions of the temperature as well as pressure. Very short trick to remember, that is S means strong forces in solid, L means less forces in liquid. Then one thing which is to be remembered here, the change in energy leads to change in state. So the frequently asked questions we can expect is the difference between crystalline and amorphous solids, applications of surface tension and viscosity concept, then gas laws and numerical problems, then phase transition and critical phenomena.